So to look at the theoretical potential for biospheric mitigation, we have to start with the main feedbacks again and then build on what the contributions of the biosphere to greenhouse gas emissions have been, so that then we can say how to reduce those emissions and enhance the sinks that are already there or additional new sinks. So let's start with this nice figure of showing the feedbacks between climate and biosphere disturbance in terms of pathogens, fire, drought, wind, snow and ice, and insects. There are indirect effects. So the thickness of the arrow here shows the evidences or the number of published reports on those particular aspects. So you can see that the thickness of the arrow here is different than here. Percentage is higher, percentage is lower, and it's the case here as well. Okay, so the upper arrow refers to the relation between the disturbance and the factor like pathogen. Here it's climate. Indirect effects, so this is the net of all these things, let's say. So direct effects are 57%, indirect effects are 25%, and then interaction effects between the climate and disturbance is about 18%. Fire, there are many direct effects, of course, and there are indirect and interaction effects as well. For example, warming, water vapor pressure deficit, impacts on vegetation, drying, then natural triggers producing fire, and the extent and duration of fires, etc., are all going to be interactions. For example, drought, the direct effect is massive, 72.5%. So mitigating direct effect is going to save you a lot in that sense. Indirect through droughts and interactive effects fairly small in this case. Similarly, wind, snow and ice, insects, and so on. For example, here snow is covering the trees. And when you think about using afforestation as a mitigation effort, a mitigation pathway, for example, you have to worry about how the albedo would be changed in these latitudes of high snow when you plant trees. Trees will end up reducing the albedo if you're not careful, so that would trap more heat. So in that case, the trees have to more than compensate by taking out carbon. But mature forests then become saturated, and they have to be protected from disturbances, which is what we are looking at here. So you can see already how the feedbacks will go, and this figure shows that kind of feedback. This is being shown for warmer and wetter climate and warmer and drier climate conditions for different regions of the world in terms of these feedbacks from fire, drought, wind, snow, insect and pathogens, and you can see the various percentages and which way they are leaning. Plus there is a region specificity to it because it depends on what type of forest it is, what are the relevant feedback factors, whether it's fire, whether it's drought, whether it's insects and pathogens, and so on and so forth. And it depends on whether it's going to be a warmer and wetter climate or warmer and drier climate. Okay, so the land biosphere contribution to climate mitigation is going to depend on these factors, which are not easy in terms of being comprehensive in the policies. In the policies, you can say afforestation as a part of the nationally determined contributions to the Paris Agreement. Let's say India promises 2.5 to 3 gigatons CO2 sink additional from afforestation, but all these factors have to be included, because if global warming creates a situation of more fires, more pathogens, more insects, more droughts, etc., how will India be able to meet its target through afforestation, land biosphere? That's not so easy. Okay. This is a nice paper from Lal talking about processes of soil degradation driven by biophysical, social, economic, and cultural factors. Puts soil degradation in the middle as decline in soil health and functionality. There are physical factors, chemical, biological, and ecological factors, and there are interactions in terms of ecophysical, physicochemical, biochemical, and ecobiological, obviously. And human activity is part of it, so that's the cultural part. Forests, livelihoods, and biomass burning, clearing for agriculture, etc., are all part of the human activity that affect the soil degradation through these processes as well. So under physical, we have I have to stop this. I have a call. Excuse. Okay, so here we are. Whoops, sorry. Talking about the soil degradation part related to various physical, chemical, biological, and ecological factors. Under physical factors, we have decline in soil structure, crusting, compaction, hard setting, runoff, drought, erosion by water and wind. So you can see that those are all climate related as well. So in terms of direct, indirect, and interaction parts, they are all relevant. Under chemical, you have irrigation, salinization of soils, pH changes, so acidification and alkalinity also comes from fertilizer applications, nutrient depletion, especially because of the monocropping or not having cover crops, not protecting the soil, elemental imbalances, again because of fertilizer use and so on. Biological, you have the soil biodiversity loss of soil, decrease in respiration quotient, soil organic matter, increase in pests and pathogens, and you have under ecological factors, you have disruption in biogeochemical and biophysical cycling, perturbation of the hydrological and energy balance. So those are again direct, indirect, and interaction effect, and each of those spheres are going to interact with each other as well. And soil degradation itself is going to feed back and interact with those factors. So this is various reports and papers and committees have made a strong case for maintaining soil health and functionality. There is no doubt at all how important soil is for the entire biosphere and the land biosphere ecosystem services, food security, and so on. And yet, it's not something that is easily considered in all the policy decisions and the various food security issues, water security issues, and so on. Soil is not considered directly in many of the actions, but it is still the basis on which entire biospheric activity happens. And human activity greatly affects soil quality and functionality. So somehow soil has to be made a big part of this land biosphere and climate mitigation. And in the other course, Bending the Curve, I talk more specifically about enhancing carbon sinks in soils. In this book, in this chapter, that's not addressed so directly. So maybe I'll add a couple of podcasts from there, or just link that chapter to this playlist as well. Okay?